So this is a tool that a colleague of mine, a postdoc in my team, Michalis, developed, and it's for the water industry. So we have, as you probably know, we have a fairly large water research center in our school. It's in the Valentine Annex. And this was a project sponsored by the Water Reuse Research Foundation in the US. And we had a partner, Hazen, which is a consultancy, a US consultancy, who was a partner in that project. And the whole idea was to assess different options, different technologies to supply water to communities. And this is both a fairly important topic for Australia and the US, especially the Western US. California, as you know, has been stricken by drought a couple of times now, and it's getting worse. Australia as well, as you know, New South Wales is officially in drought. We had rain, luckily, so it has eased a little bit, but it was not really a drought breaker as such. So we are still officially in drought conditions, and you might have heard that this is a problem, especially for rural properties that live from the land, mostly raising livestock here in Australia, but then a fair bit of farming and cropland in California. So that project involved both Californian partners and US and Australian partners. And because both are quite interested in what is the best water supply. So obviously water, if we have more droughts, then water is becoming more scarce. Also the aquifers don't refill as they maybe previously did. And so in some parts we see sinking levels of water in water aquifers. And that of course then is a problem in itself, because you can't use bore water as much as you maybe would have used it before. So the challenge is really how can you come up for, well, both for towns as a town water supply, but also maybe for agriculture to some extent, with water supply that is sustainable. We also included reuse of water in that as one option. And I'll tell a little bit more about that. There's a couple of different options how you can recycle and reuse water. But we will, increasingly, engineers will have to look into all of these options, because the problem is only getting worse, really. So what we created here is an assessment framework. So there's, a couple of photos from some time ago, but it probably looks quite similar now. A tool that would calculate the triple bottom line impacts, so economic, social, and environmental impacts of different water supply options. I mentioned already that we had this partnership with Hazen and Sawyer. There were also a couple of water utilities involved, both from Australia and California. And together with them, we came up with developing that tool. Had a couple of workshops and industry surveys where we asked them what's important, what do they need to know. We used life cycle assessment data and then input-output data as well to create a quantitative tool. And MCDA, so this is what you will use in the assignment as well. We'll talk about that separately. Multi-criteria decision analysis. So all of this went in there. This is just an overview of the different water supply options. I will tell a little bit more about the two different types of reuse, direct and indirect potable reuse. Building new dams or raising dam walls, that's in discussion for Sydney as well. That's not technically too difficult, but has problems on its own, because you might flood valuable habitat, and that might be a problem. Groundwater pumping depends on how much groundwater we have. Stormwater harvesting is a nice thing to do, but you need the infrastructure to be able to capture a lot amount of water that comes down in a very short amount of time. Extending other supplies. So this is basically building new pipelines from places that are further away and have more water to the one where you need the water. The demand management. Demand management basically means educating people so that they use less water. And that worked really well. Have you been here? Maybe not. I wasn't here. In the early 2000s? Who has been here in the early? Yeah. So I don't have the graph. It's not very quantitative, but it's basically this is time, and this was, if this is the year 2000, then this was before. And this is roughly how many liters per person per capita were used. And it was roughly around 400 liters per person per day, which is a lot. Here. And then there was a drought, about 10 years of below average rainfall, something like this. And then all these restrictions came in place, and so people were forced, basically, or asked to reduce their consumption. It went down to about 200 or 250, maybe not quite half, but almost half through these measures. And then the rain came back, so it then 2010 and later. But what happened is that the level actually did not go up back to 400, which is a good thing. So people changed their habits and also changed some technology, and that more or less stayed at that level. So this is a good example of how demand management can actually make a lasting change. So it can be regulation, it can be just putting the right incentives in place. Some of it can be voluntary. So there's different ways of managing. Now, we tried to do this a little bit with energy consumption now, trying to get people to buy energy-saving appliances and so on and so on. Okay. Dual pipe, purple pipe is using rainwater, recycled water in addition to town water and then water imports. So triple bottom line wise, we had these indicators. So for social, we had things like acceptance, risk, reputation, but also employment, income, and so on. For economic, we had the costs, but from a life cycle perspective, so across everything, not just the water supply itself. Value-added profits, and so on and so on, capital costs. Environment, we looked at energy, carbon footprint, toxicity, land footprint, and eutrophication. Why do you think a public acceptance is important? Yes. So, the reusing water or recycling water has a bit of a problem with public acceptance, because basically people think we take our wastewater and recycle it and then we drink it again. And that's what we do. And it's technically perfectly safe, but the perception is that maybe the water is not as clean as it should be. So it's more a psychological thing than a real technical problem. But it's still real. People still are not comfortable with the idea of recycling water, depending on how it's done. So that's why public acceptance is actually quite important. Yeah, we don't need to go through all of this detail, but that was the different things we included. So we had a hybrid LCA model, included like operation and construction phase. This is our input-output table. So we had, because we had project partners in Australia and the US, we had Australia, US, and then we added China as a third country here, because China produces a lot of the equipment that's used. And so both countries import from China. Back then, they still did import from China. So we thought it's important to include that as well, and the rest of the world, just for completion. So a multi-regional input-output table with extensions, and then we did some specific adjustments. So hybrid LCA, again, for the chemicals, we did specifically put in process data on chlorine and electricity, concrete, and a few more things that are just were needed to make the table specific to the technologies that we wanted to investigate. So that's the hybrid LCA part of that. Then everything was coded in MATLAB. You know how that works now. We adjusted electricity data so that they represent state level, because that's important. Where you build your plant, different states and territories have different power generation. And then a few additional specific processes, like how the sludge is disposed and so on. So all of that was included. And we ended up with that list. This is the table that you will use for your assignment as well. So that has the range of economic, environmental, and social indicators that we took into account. So here you see what they are in detail, a little description, the unit, and then this refers to whether we have quantitative data or whether it was a qualitative indicator. But the qualitative indicator can be quantified as well if you estimate likely impacts on something like a scale from 1 to 10, or you can define this, but you can put numbers to that, and that's actually what you will do in the assignment as well. I'll explain that. So range of indicators, then you can look at different water supply options. You can produce a graph like this. Again, you have seen that before. So comparing one option with another one, whereas the other one is normalized. So you see where the impact is larger or higher, larger or lower. MCDA allows you for each indicator to come up with an aggregate score. And that's what the tool can do as well. And then basically we had that tool, and this lists what was important for the decision-making process, so that we could have all the processes that were necessary to include, that the weighting of criteria, I'll get to that, is important and transparent, and that you can use this to make an assessment and compare two options to each other. But of course, the modeling is based on the data that you put into the model, and it does not represent maybe a large-scale change once you have rebuilt the whole economy.